All right. So I'll go ahead and I'll record the lesson too, so that we can post it and everybody can have this same review in case this is what we talk about is difficult or new for you. All right, the slope is the rate of change of any linear equation. So when we have a linear equation, that's x to the first power, here's a really amazing thing that happens. All of your solutions to that equation line up in a straight line. When x is to the first power, all of our solutions end up all in a nice straight line. It's crazy the way that it happens. When we look at how that line is changing, we're looking for the average rate of change, and we call that the slope, where we look at the change in our y coordinates and we compare that to the change in our x coordinates. When we talk about slope, we're talking about coming up with that value where I take those coordinates, that x and y, and I can calculate how much is changing in one respect compared to the other. So if you look at these coordinates on this note sheet, I have -4, -3 as this coordinate, and I have 5, 3 as this coordinate. Now, if I have a graph, finding the slope is easy. I count 1, 2, 3, 4, 5, 6. My rise is 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So my change in my y's was 6 units. My change in my x's was 9 units. And then I know that I can simplify that fraction to 2/3. In fact, if I went rise 2, run 3, I find another integer coordinate. Rise 2, run 3. Rise 2, run 3. And when I talk about an integer coordinate, here's what I mean by that. If the line is going through where the grid lines cross, that's what we call an integer coordinate. An integer is a whole value, positive or negative. So when I'm counting on a graph, I'm looking for where does it cross my grid lines, where does it cross my grid lines, where does it cross my grid lines, and those are my integer coordinates. If I wanted to do the calculations, instead of counting on the coordinate plane, I can go ahead and take these xy ordered pairs and I can set up where I'm finding the change in my y's. And it doesn't matter if I'm going from -3 to 3 or 3 to -3, I'm going to get the same answer. So -3 minus 3, and the change in my x is -4 minus 5. Now here's what you need to know. As soon as I choose this coordinate first for my y's, I need to choose this coordinate first for my x's. -3 minus 3 more is -6. -4 minus 5 more is -9. A negative divided by negative is a positive, and I can simplify that fraction. Notice I get the same rate of change. All right. When we're talking about rates of change, we have 4 different conversations that we can have. We can have a rate of change that's positive, and if that rate of change is positive, it is increasing as x gets bigger and bigger. If we have a rate of change that's negative, we have a slope that's decreasing, an output that's getting smaller as x gets bigger. 2 words that we use in Algebra 1 sometimes are hoy and vux. Let me tell you what those 2 silly words mean. A horizontal line has a slope of 0, a y-intercept, and a y in the equation. We call that ahoy. Guess what? No one else calls it ahoy. It's not in a textbook. It's not going to be on YouTube. You can't Google it. It's a little bit of a Herndon thing. It's a Fairfax County math teacher's thing. Somebody came with it and other teachers were like, oh, it's pretty cool. I'm going to use that too. Kids that I taught 10 years ago still remember hoy and vux. So it's not a real thing, but it's just something that helps us remember it. So when you see the word hoy, horizontal line has a slope of 0 and a y equals in the equation. Knowing that HOY stands for horizontal line, slope of 0, y in the equation, would you please talk to your group about what you think VUX stands for? Go. All right, I heard it and I love it. It's a vertical line, has an undefined slope, and it has an x-intercept and an x only in the equation. So when you look at those vertical lines, and it's confusing for kids a lot of times because I know that this y-axis is an up-down axis, but whenever I have a y-only equation, I get that vertical line, or I get that vertical movement. Y can be up high, y can be down low. Y is equal to that, ends up being a horizontal output. With an x is only, then I'm talking about just whatever value for x. So even though my x-axis is left or right, my x equations are vertical. Kind of get that straight in your head. All right, we talked about 3 different formats of linear equations. Linear equations can be in standard form, and that's where you have an a and a b on the same side of the equal sign. Those are our coefficients to our x and y terms. And here's the cool thing, a and b are whole values, no fractions, and that's one thing we can add to this conversation about standard form. No fractions, we only have whole values. When we talk about slope-intercept form, this is the granddaddy. Everybody loves slope-intercept form because for every linear equation, there is exactly one slope-intercept form. And that format tells you the slope, and it also tells you the y-intercept where this graph crosses my x-axis, my y-axis. I wanted you last time we were together to work with point slope form, and point slope form is what geometry and algebra 2 and pre-calc and calculus teachers use, because once you learn y equals mx plus b, it's 2 extra steps to solve for that. So with point slope form, we can go ahead and just put everything into one equation and then simplify it. Point slope form will always simplify to y is equal to mx plus b. If you're curious about where point slope form comes from, that's what all this math up here was when I was showing 6th period yesterday. If I have this original slope equation, slope is equal to y2 minus y1 over x2 minus x1, I want you to think about multiplying each side of this equation by what's inside of this parenthesis. These will cancel out, and this times m is equal to y2 minus y1. If I take this equation and use the symmetric property of equality and flip it, I now put my x's and my m's on this side and my y's over here. Because I'm plugging in one point and every equation has an open x and y, I can forget about that second point and just have that be my x and y. My point slope format is derived from my slope formula. So you have 2 choices. You could understand three choices. You can memorize it, you can understand how to derive it, or you can just continue to plug in for your x and y and your m and solve for your b and then go back. Alright, so on the back of this, I wanted you to complete these conversations about what the heck does this have to do with geometry. Right now you're feeling a little overwhelmed with algebra. You're like, wait, what class did I sign up for? So when we talk about the slopes of parallel lines, those lines are always going to increase or decrease at the same rate. Therefore, they're never going to meet. Therefore, that's what makes them parallel. Any two vertical, any two horizontal lines are going to be parallel by their definition. So when we look at these lines here, we can take a look at how to calculate their slopes. So I can go ahead and I can say that for J1, rise 1, 2, 3, 4, 5, 6, 7, 8, and run of 1, 2, 3, 4 gives me a slope of 2. For J2, I have a rise of 1, 2, 3, 4, 5, 6, 7, 8, and a run of 1, 2, 3, 4, which again gives me a slope of 2. For J3, I have a rise of 1, 2, 3, 4, 5, and a slope of 1, 2, 3, giving me a slope of 5/3. So these two are my lines that are parallel. This one, if you look at it, is not quite as steep. This one is tilted a little this way, and as these lines continue on forever and ever, you can see that that distance between them is going to increase, and eventually down here on the paper, they will intersect. So if line K1 has the equation, y is equal to negative 2, x plus 5, and line K2 is parallel to that, that means it has the same slope. So all I need from this equation is the slope. If K2 passes through this point, write the equation of K2. I went and I got my point slope form. I plugged in my y, I plugged in my x, I plugged in my slope, and I simplified to point slope form. Would you please take a moment and with your table group either together repeat what I just did or use y equals mx plus b and solve for b. On your mark and set, go. Alright, so now comes the fun part, talking about slopes of perpendicular lines. When we talk about the slopes of perpendicular lines, it's so important that we understand the concept of what it means to be perpendicular. So if two non-vertical lines are parallel, that shouldn't say parallel. Two non-vertical lines are perpendicular. Anybody curious about that? If two non-vertical lines are perpendicular, then the product of their slopes is -1. So what I want you to do is I want you to think about what it means to be perpendicular. So would you please mess with some pens, grab some pens out of the basket, and what I want you to do is I want you to go ahead and arrange two pens so that they look like they're perpendicular to you. Okay? And then go ahead and take those pens and spin them and play with them to try to get them to maintain that perpendicular relationship. Alright, so think about this. If two slopes were opposite, can you do this with your pens? Can you make the pens really tall and skinny? This would be like a slope of +4 and -4. Right, Owen? +4 and -4. In any world, are these perpendicular? No. So now I want you to do a slope that's really steep, that's positive, like +4. Now I want you to do a slope that's pretty flat, like +1/4. Do these look perpendicular to you? in any world, are these perpendicular? No, because what you need is two things to be true. You need the slopes to be opposites, and you need them to be reciprocals. So if this one is steep, this one is flat. If this one is flat, then this one is steep. And you can kind of spin those pens and get that look of what it means to be perpendicular. If two non-vertical lines are perpendicular, their slopes are opposite reciprocals of each other. The cool thing about that is the product of their slopes ends up being -1. Let's take a look at this. Do you see this steep line? It has a slope of rise 2, run 1. So my slope is +2. Take a look at this one. My slope is down 1 over 2. So my slope is -1/2. If I were to multiply -1/2 and 2 together, I'd get -1. All horizontal and vertical lines are also going to be perpendicular. So when you look here at the notes, J1 and J2, J1 has a fall of 1, 2 and a run of 1, 2, 3, 4, -2/4. That simplifies to -1/2. J2 has a rise of 1, 2, 3, 4, 5, 6 and a run of 1, 2, 3. That simplifies to 2. These two values are opposites. One's positive, one's negative, and they're reciprocals of each other. All right, so that's your note sheet. Everybody good with that? Now we're going to have you take out your homework. And when we have you taking a look at your homework, we're going to talk about this bit by bit. Solve each equations for y in terms of x and circle the slope of the equation. So one of the biggest things that you need to know how to do is to isolate y, to get y on one side of the equal sign all by itself, because whatever y is equal to is going to give you a lot of information. I'm going to get my slope and I'm going to get my y-intercept. With your group, please, will you check in with each other on solving for y? Your mark is at go. I love this graphing and this conversation because we give you one of each different kind to help you get it right. So here's a horizontal line. There it is. All the y's are equal to 3. So there's my horizontal line. Slope is 0. Y-intercept, y in the equation. Skipping to number 5, here's my vertical line. X is equal to -5. Vertical line, undefined slope, all my x's. Every x by ordered pair that sits on this line starts with an over -5. Hey, this one is an equation that's in standard form because 3 and 4 are integer whole value coefficients. I love graphing this by using an intercept table. If you substitute 0 in for x, when I was teaching algebra, we called this the cover-up method. Because put your finger over 3x. You substitute 0 in, 3 times 0 is 0. So 4y is equal to 12. That's an easy thing to solve. Y is equal to 3. Put it down. Now cover up this one. Plug 0 in for y. 3 times what number is 12? That's 4. So then I just went ahead and graphed over 0 up 3 over 4 up 0. Connected them and there's that line. Here's a direct variation because I have no constant. It goes through the origin and I have a slope of 2. Here's our classic slope-intercept form. Here's my intercept at -5. And my rise over my run, I'm going to fall 3, 1, 2, 3, run 1, 2, 3, 4. If you rise 3, 1, 2, 3, you can go back 1, 2, 3, 4 and still end up on the line. This linear equation has a constant rate of change. That rate of change is decreasing because of the negative at a rate of 3 to 4. All right, for 8 and 10, label the two integer solutions. The word integer, remember, is a whole value that's positive or negative. So when we're looking for integer solutions, remember that's where it crosses the grid lines. So you're going to pick solutions where the graph crosses at the grid lines. And then if you count the rise over run, rise 1, run 2, rise 1, run 2, you can see this one has a slope of positive 1/2. My integer solutions, fall 1, 2, 3, run 1, slope of negative 3. And then of course here is ahoy, a horizontal line with a slope of 0 and a y in the equation. All right, on the back. Slope of a vertical line, undefined. Slope of a horizontal line is 0. Vertical line is an undefined. And the vux, horizontal line, is ahoy. A ratio that defines slope, rise over run, change in y compared to change in x. And then we have that formula. And pay attention to this formula. Whether I put this point first or this point first, it doesn't matter. My answers always work. Parallel lines have the same slope. Perpendicular lines have a product equal -1, or they're opposite reciprocals. You and your partners right now find the slope of these 3 lines on your mark, get set, go. All right, check your work with mine. Check your work with mine. 3 minus 4 is my change in my y. When I do 6 minus -3, that minus and negative is plus a positive. -1/9. The middle one, 3 minus -4, ends up being plus a positive, 5 minus 3. That last one, because these two outputs are the same, I know that I have 0 rate of change. So it doesn't matter what's down here. I know that's a horizontal line. All right, next up. If you're given a line with these solutions, we want to find the slope of the line. 8 minus -3 compared to -2 minus 4. Everybody okay with that? If you screw up on the slope, you have no chance of getting the equation of the line right, so we need to make sure you've got that right. Letter option B asks you write the linear equation in point slope form. So with your group mates, go get point slope form. Here it is. Force yourself into doing it. Y minus. Now here's the cool thing. You get to pick whichever one of these points you want. You get to say, oh, I like 4, -3. Somebody says, oh, no, I like -2, 8. Y minus, the y value, is equal to the slope times the quantity. X minus, and you have to pick the x from the same coordinate pair that you pick the y. Make sense? Let's see how you did. Which one did you choose? Did you choose 4, -3? Or did you choose -2, 8? That's the equation in point slope form. All right, next up. When we write it in slope intercept form, you're going to take whichever version you did, and then you're going to do the math and simplify. So think about this. There's an infinite number of point slope forms for an equation, but only one slope intercept form. So if you chose this, it'll simplify to this. If you chose this, it'll simplify to that. Kind of cool. When we write the equation in standard form, I'm going to add this and put my x and y on the same side. And I'm going to multiply by a factor that's going to eliminate my fractions. So that's what I end up with here. Now here's a crazy concept. You can check your work every time. Every time you write a linear equation, you can plug in the x and the y, do the math, and see if it works out. You can plug in the x and the y, do the math, and see if it works out. All right, with your group mates, complete those following 3 questions at the bottom. And your mark it, set, go. I did. The equation of a line parallel goes to the origin. It's got to have the same slope. Equation of the line perpendicular. My slope is the opposite reciprocal. If it has a y-intercept of 9, that's what goes in there. All right, so here's what I need you to do for tonight, for next class. That warm-up, hold on to it. Come in ready to go. And you ask questions. I want you to do it. This review packet is a review packet for the test that is on the 8th. Start it. Come to class with questions. See you later.